Hi, I'm Richard Zeta with the Route 10 Aircraft Flying Experience, and I'm here with Lady Vi, the world's only flying Variviggen, and it's also a new Viggen in the 50th anniversary of the Viggen. So we got a lot of firsts here on a really cool airplane that's unique and kind of different. Not too many of these were around, about 36 of them or so we think were built. Bert sold 1,000 or 1,200 plans, but then the Very Easy came along and a lot of people shifted over to building that. So the Variviggen started this whole line of unique canards, the Bert Rutans, and I'm going to take you around and show you some features about the airplane and what makes it kind of cool and neat and unique. So come on aboard. I'm going to get in the cockpit first and we'll show you what that's about. Just getting in is different. As you see, I have a boarding ladder. It's a really tall airplane. Bert was a really tall guy, but he still needed some way to get in. Once you get inside the cockpit, it's really comfortable. There's quite a bit of leg room. The panel was built by the original builder of this panel right here, Harry Patterson, and then all of this equipment was donated to us. We replaced the panel. It's Grand Rapids Technologies EFIS that was donated to us. And then the tachometer you see is because technology sometimes has challenges, and the dual light-speed plasma 3 ignitions don't talk well to the Grand Rapids stuff, so we needed a tachometer. We got this one out of a very easy project that was donated to us, and it works just fine. So that's kind of different, but ultimately we'll get all that fixed. The switches are pretty simple. They're pretty labeled. It's a very basic airplane, but it has some controls in it that are different. You know, the stick's the stick. It does the same thing other airplanes do. Pitch controls through the elevator on the canard. This knob right here is the manual nose gear release. So if for some reason the nose gear doesn't come down, you move this knob over and it free falls down. The gear is different on this airplane. There's two separate systems. The nose gear has its own motor. The main gear has its own motor. They're operated by the same single switch, but the circuit breakers break up the two different systems, and then all the indicator lights. We've got gear down lights, gear in transit lights, a gear unsafe light that comes on when the throttle's back at idle, and up here is an angle of attack indicator that's got a vane on the nose cone, and when the gear is up, the angle of attack indicator will not light up. So it's a secondary indication that your gear is up. Other than that, radios, transponders, all that stuff. Back down in here, there's more levers that look different. This one's a pitch trim. It's just a spring centering stick feel. Then you move it up and down based on where you'd like to have your pitch trim. These levers here deal with the main gear. One lever releases the up locks, and the other lever pulls the motor away from the main gear that cranks down both gears. And when you pull that motor away from it, disengages that motor, then you can use that crank to crank the main gear either up or down, actually. So that's the backup system, the main gear extension, if the electric motor or something else kind of fails. So the other controls are fuels right over here. It's just on and off, very simple. On the throttle side, we got a throttle and a mixture control. It's fuel injected, so there's no carburetor heat. And this is the friction knob right here. And then this is the canopy latch. And that's pretty much it in the front seat. So I'm going to climb out and show you some stuff on the rest of the airplane. The boarding ladder I fold up and just put it right inside here. This leans up just fine, and I take it with me because without it, I can't hardly get in and out of the airplane. So the back seat, originally when this airplane was built, this panel came all the way out to here and had like a little baggage compartment there. We really didn't need that, so we trimmed it back. These are more instruments that were donated to us, the third EFIS screen and a Grand Rapids EIS, and then we put this shelf in here to hold the AHRS, magnetometer, and some other stuff. So it's very compact, lots of leg room back here. There's no stick in it right now, but it's got full controls, front and back cockpit, stick, rudders, throttles, all that stuff. So you can be flown from either seat, but the pilot sits up front. So Behind that is kind of a baggage compartment. We won't pull the seat out, but our electronic ignitions are back there, the main gear motor's back there, and a bunch of other stuff. So the whole airplane is made of wood, except for the outer wing panels. And a lot of people say, oh, I didn't know Bert made metal wings. I thought he made composite wings. He did. A couple of years into the Variviggen project, he built the SP wing, which was the first composite thing he ever made, and it improved the performance of the Viggen tremendously. It's a higher aspect ratio wing. It had winglets on it, had more fuel in it. Our fuel tank is right in here. It holds 30 gallons. And that doesn't sound like a lot, but the engine was originally design was for a 0320 or an 0360. The engine we had donated us was an angle valve IO360, so that's what we used. Kind of like the Boomerang. People asked Bert why he put two different engines on a Boomerang. He said, that's what I had. So that's what we had. And if you saw what I was sitting on in there, the good news is this burns a lot of gas, and I only have 30 gallons of gas. So about every 2 hours I'm ready to land for two reasons. One, I'm out of fuel, and I'm tired of sitting on that seat. We didn't have really time to do much as far as the seat goes, so I got a couple of memory foam pads and kind of a boat cushion. You know, but we're at Oshkosh, that's what's important. So that scoop down there serves the oil cooler. Pacific oil cooler gave us a really nice big oil cooler, and our oil temperatures are just awesome. That's the inlet for the engine, and oil dipsticks right up there. And this side has a wing walk. The other side does not. If you're building a Viggen, put a wing walk on the other side because you're going to be over there. The wings come together right here. There's a little bit of a leading edge mismatch between the two panels. Who knows why? I'll have to ask Bert one day. But this fence kind of hides that. His fence was actually a little bit shorter, and we extended it all the way out to here and oil flowed it and found that that helped quite a bit. So let's talk about the landing gear. The main landing gear, everything retracts on this airplane, and these main landing gear are in the plans. You weld them up. It's not something removed from some other production airplane. They both move inward. They're driven, it's kind of a complex system, but there's an old Ford window motor in the center section that drives a gearbox of 3 bevel gears that spin torque tubes that go out to the wheel well. And then there's a worm drive and kind of Boston gear arrangement that rotates the gear up and back. It's really pretty simple. And it's all stuff you built. You didn't get parts from anybody else except for the Ford window motor. So the outer wing panels on this airplane are metal. We talked about that before. We polished ours because they weren't painted, and we thought we had never seen one with polished wings before. Originally, we thought we were going to have to build a wingtip, and as we were approaching getting to Oshkosh, we were in a flurry. I said, somebody's got to build a wingtip. Well, what do they look like? We went to the plans and realized there was no wingtip. And the plans drawings don't show a wingtip. We'll eventually put one on there because we don't have nav lights or anything, and just this counterweight for the ailerons, and that's it. Ailerons are full span. It doesn't have flaps. Our elevator's up front with the canard. But a real unique feature of these ailerons is they use reflex to help manage lift with the wing, kind of like flaps do. The trailing edges of both ailerons will go up to 8 degrees. And on the stick there's a trim button. Looks like a regular coolie hat trim button, but that controls our reflex. 8 degrees of reflex is used for takeoff and climb, and then as you accelerate, you trim the reflex out down to 0 in cruise. It's kind of like, it changes the camber of the wing artificially like the flap kind of does. It's just a different way of doing it. The aileron travel also changes a little bit with the reflex, and all of that's controlled kind of uniquely by a motor that pulls on a stack of pulleys that changes the cable tension, which moves the aileron trailing edges up and down. It's really pretty ingenious. That's just a very simple way to do it. So when we were first trying to rig the airplane, we're digging through the plans, and trust me, I've read every page of the plans, and we were trying to figure out what kind of cable tension this thing needed, and Bert said, it's about 10 pounds. Just pick up a 10-pound weight and about that much. So you don't use a cable tensiometer on a system that varies cable tension to move the flight controls. It's really different. The rudders, Well, if you're familiar with very easy and long easy rudders, where you can step on each one individually, and you step on both of them to make brakes, we'll let the tri-motor go by. This one doesn't do that. The Viggen rudder pedals work just like a regular airplane, just like that, and it has toe brakes. But there are other differences on the very easy and long easy. When you step on one of those rudder pedals, that rudder extends and retracts, and that's all it does. The other side doesn't do anything because they're not connected. These are, there's a balance cable in there, and each rudder moves in unison with the other, but at a different rate. There's a bell crank in there that varies the degrees of travel, so this rudder may move full travel, and this one will move slightly less, about 50%. So that's another unique feature of the airplane. The vertical stabilizer here are kind of like our rudders. They're bigger than the original vertical stabilizers on 27 Victor Victor, which is Bert's airplane, to give it more directional control. So we move back in here. This is what I call the beaver tail area. Like I said, we got a big old motor in there, 3-bladed Kato prop. And another unique feature of this airplane was when we first hung the engine on the engine mount, it didn't quite fit. So rather than change the engine mount, we built our own custom cold air induction. We actually gutted the oil pan. We put a vertical oil pan in there, a Lycoming vertical pan, and gutted out all of the cast aluminum induction tubing. That saves 7 pounds. It's really worth the effort. And then 2 plates welded to the oil pan hang the throttle body right in there, and that lent itself really nice to having the cold air induction on the back of the motor. And how we made this was really so simple. These are the original intake tubes. I just pie cut them and rotated so they get the direction of turn I needed. Joined them all together in this arrangement, took a big block of blue styrofoam, carved out this pleasant shape of a plenum, wrapped it in about 5 plies of carbon fiber, and then made these junctions to the tubes, and that was it. When I was done carving the block of foam and wrapped it in carbon fiber, and it cured, I threw it in a bucket of avgas and went to lunch. When I came back, the blue foam was gone, and I had this nice plenum. You know, we painted it with epoxy to make it shiny. And the only reason there's carbon fiber all the way up to here is because I'm a really terrible welder, and I was worried about my welds, so I wrapped them in carbon fiber. But we're really, really happy with this. It was the first time we'd done it. We've been thinking about doing it for a while. All our EGTs are within 20 degrees. And a fuel-injected motor, that means that the nozzles are tuned well and the airflow is tuned well. So if you're thinking about cold air induction, it's not that hard. If I can do it, anybody can do it. So BNC donated this starter and alternator and a regulator. One of the cool things about this airplane is Routine Aircraft Flying Experience is a nonprofit. And this airplane is here at Oshkosh today because of volunteerism and donations. If it wasn't for our volunteers that came and worked on the airplane and the companies that offered us equipment to make the airplane fly, like I said, even the engine was donated to us. It wouldn't be here today, and we wouldn't have a Viggen on the 50th anniversary of the Variviggen. So Pacific Oil Cooler gave us that cooler. Klaus Lightspeed Ignition gave us the ignitions. I mean, the list goes on and on and on. But we're really grateful for that. Sabre gave us the prop extension. It's just really great. And then an individual gave us the long easy pipes. He had just had them ceramic coated. He was real proud of them, and I mentioned that we needed a set of pipes and this and that, and he said, well, here, have mine. And we were grateful for that. So that's basically straight pipes right out of long easy. So the engine runs really, really well. The actual engine came off of an Aero Canard that one of our members had, and he wanted an IO 540 on his Aero Canard. And he found one, and he turned to me and said, could you use my 360? And I said, well, of course we could, and put it on the Viggen. He said, okay, and so he donated the engine. It was the easiest engine swap I've ever done, because we literally unbolted the 360 off his Aero Canard and wheeled it across the shop on the engine hoist and bolted it to the Viggen. Of course, that's where it ended right there. We had to go through all that stuff to make it fit. So this section right here is kind of cool because it's unique to any, I don't know of any other airplanes that have it. And the nice thing about having a Kato is it doesn't arc down in between the beaver tails, so if you have to land the airplane gear up for some reason, you won't hurt your prop, nor will you hurt your airplane, because if you look down here, there's these little dorsal fins that have a little wheel on them. And if the main gear don't come down, you can land on your nose gear and these little wheels and not hurt the airplane at all. And I met a gentleman here, Rob Smith, who got probably the highest time in any Viggen pilot, flew his Viggen for over 20 years, and he told me he landed it once on those wheels and did $10 worth of damage, and that was because he tore up the little wheel and he just replaced them. So we don't want to do that, but in case you have to, that's a nice feature of the airplane. So coming back around this side, there's another thing that we all kind of laugh at. Remember, we're trying to get this airplane to Oshkosh. There really wasn't a good way to build an air box in there for the induction system. We had a K&N filter, the bolt, on a flange in front of the throttle body. We went through all this trouble to make this cold air induction, and then I realized that the K&N filter is right next to the oil cooler exhaust, and it's underneath the engine, and our cold air induction is going to be ingesting hot air. I said, well, we got to get that outside the airplane somehow, and there wasn't a good place to build anything to hold the K&N, so we put it outside, and we built this horrendously large air filter scoop, but it works really, really well. But it also proved to us that aerodynamically it's not very efficient. There was a bunch of oil, we had an oil leak and oil stream down here, okay? And right here there was another oil leak that came out that actually reversed up and came in and joined this one. And then it was really indicating, if you ever done oil flow tests, of how bad that was as an idea. What we're going to do later on is take all that stuff off, both the scoops off to the side, and put a P51 scoop on the belly. And we couldn't do that because we didn't have time, and we weren't sure where we could open up through the structure in here in the beaver tail. But earlier this year we had another Viggen donated to us that was incomplete. It had never been skinned. So it's just like a skeleton of a Viggen. And it's all kind of see-through, and we realized right away we could do that P51 scoop and it would be easy. So we just didn't have time. This was easy enough for our volunteers to do. So there's the other twin rudder there. And like I said, both rudders work together. Another full span aileron, shiny metal wing. Flitz donated a bunch of stuff to us to help us polish the wings. This airplane was started probably 25, 30 years ago, and over that time, these wings have been, a lot of hanger rash on them, but they polished up real good. I'm real happy with the Flitz process. If you got to polish something, use that. It worked really, really well. So we're back over here, same thing. The wing bolts are underneath this little piece of Mylar. And one of the things that we learned about it when we first got the airplane together, well, we needed wing bolts, okay? But we started digging through the plans and we realized that it doesn't just use a bolt, it uses 2 taper pins, and we didn't have them. We started looking at the wing attach fittings and we realized that they had been tapered out to hold a taper pin and get into plans. And there's a little drawing of these taper pins that need to be made. They're made out of an AN5 bolt, a 1/2-inch bolt. And we tried to make our own on our machine shop equipment, but we found a company there in Covington, Tennessee that would make them for us. And it's really odd to mention, it's like a 3.2-degree taper. And then there's a note by Bert in the plans that says that the 3.2-degree taper is so it matches a standard Craftsman tapered reamer. Brilliant. So we didn't have any reservations about the taper pins we made, and we put it all together and it fit nice and tight. It's an AN4 bolt that goes through the taper pins to hold it in place, top and bottom. There's another an AN4 bolt there that holds the aft spar, and bolt to connect the ailerons. The wings come off in 15 minutes. Another interesting thing about why this airplane's dimensions are what they are, the canard, which we'll get to in a second, is 8 foot wide. The center section here is 8 foot wide. Can anybody guess why? So it fits on a trailer. And you don't need a wide load. It fits nicely legally on a trailer. That's pretty smart. So the dual canopies, they're great visibility. The latching system's a little odd. I can show you that to you, but they work great. And here's the canard. It's a very short span, low aspect ratio, thick airfoil canard, because it's not as wide as long, easy, and doesn't have all that stuff. The elevator doesn't have a lot of trailing edge up direction. This canard basically controls the airplane in pitch by managing lift all the time. There isn't much nose down on this, there's just less lift. This device here, we call it a bird wing, is a little trim tab, kind of like a spade on an aerobatic airplane, and it's designed to help manage the pitch loading of the airplane. So, and we also realized the bird wing on the other side, it's really easy to break getting in and out of the airplane. So we were really careful around them. But that was an add-on later in the plans. It's hinged down here, so it has the correct arc as it moves through its range of motion. And that's because this slot right here, just like on the Variviggen, is very important. You would never put any kind of gap seal on here because you want to have that airflow over this elevator. So if you look at other long easy and very easy guys, they're taping up their airplanes everywhere except right here. Don't do that, that's bad. So one more thing about the wing. From up here we can see this real well. If you look back at the wing, it's totally flat on the bottom. Well, most airfoils aren't like that, but there's a note in the plans that says the wing is flat on the bottom, so it's easily made on a table. Now, right here's another, we'd mentioned this earlier, this is the vane for the angle of attack, and it's also very simple. There's just like a circuit board card in there with a couple pieces of copper tape, and there's a brush, a little contactor on the end of this thing that rotates, and when it contacts one of those little copper tapes, it produces the connection to either light up the red light, the green light, or the amber light, and in some places it'll light up both. Really simple. So nose cone, landing light, things happen. We were moving stuff from one hangar to another, and the nose cone fell out of the back of the truck and cracked the light. I had a Band-Aid on here, but my buddies thought this was funnier. So yeah, we don't have a landing light in there yet because we don't have nav lights yet. So like I said, we just got to Oshkosh. On Friday we flew off the last of our 40 hours, and then we flew to Oshkosh on Saturday. So pitot tubes up here. The nose gear, I mentioned that the landing gear you get to weld up and make yourself. The nose gear uses a maul tail wheel. That's probably the only off-the-shelf thing on this airplane. And it folds up, it retracts up forward into the gear well, and it really needs a nose gear door right here because it gets kind of loud. But each landing gear has its own motor. This one's operated by a motor that has a chain and a big gear right there, and it spins that one way or the other, and just the nose gear comes up in about 3 seconds. The main gear, however, takes about 20 seconds. Yeah, that forward window motor is a little bit challenged by getting that stuff up, but it does the job. So, pitot tube under here. Back to the canard again. That's it. That's simple. Rutan Aircraft Flying Experience.org or RutanAFE.org. Either of them work. Just Google us. We got pretty good internet presence. There's a lot of information about our organization, our nonprofit, and how you can get involved flying these airplanes. We have 9 airplanes donated to us that fly. And we need volunteers and pilot volunteers to help them fly them. And what we do, our mission statement is preserve and promote Burt Rutan's home-built designs, the ones he sold plans for. And we have several long easies, several very easies, and now we have a Viggen, and we're halfway there. We're trying to get a Defiant, the Quickie. Actually, we have a couple Quickies that need to be rebuilt, and our holy grail is the Solitaire. I only know 2 of them that fly. So, well, one day maybe. But that's what we want to do. We get these airplanes and bring them to Oshkosh, bring them to Sun and Fun, bring them to fly-ins, pancake breakfast, and keep Burt Rutan's airplanes relevant and out in front of the public because they're great airplanes and we don't want them forgotten.